This is Advanced Math 10.4 homework questions. Advanced Math Unit 10, Lesson 4 homework questions. I didn't get any emails on questions from this lesson, so I just picked a few. I'm going to do these four for sure. This one we'll see and how much time I'm taking by the time I get there. Okay, starting off with 25. So these are just a handful of ones that I picked that students typically have asked in years past. Okay, writing it down. This is what the book problem has. It's asking us to sketch, and again we find all of these pieces. Ba, ha, sa, x-intercepts, y-intercepts. You may not have been doing the saw at this point, but I'm just going to write it down because we've already talked about it, and I'm just getting used to it. So I'm leaving it there. If you don't have it, that's fine. Okay, domain, all reals, such that x cannot equal 4. There's nothing to reduce. Vertical asymptotes, also cannot equal 0 because there's a 0 there. So 0 and 4. Vertical asymptotes, x equals 0, x equals 4, two separate, and they both have a multiplicity of 1. Horizontal, we take the limit as x approaches infinity. And is it top heavy, bottom heavy are the same. Degree of 1 at the top, degree of 2 at the bottom, that's bottom heavy. So y equals 0, which means there is no slant. Slant only happens when it's top heavy, which this is not. X-intercepts, I make the equation equal to 0. The bottoms always cancel out. 4 by itself cannot equal 0, so x plus 1 equals 0. You subtract, you get -1. The multiplicity is 1, which means it is a cross. Y-intercept, you plug in 0. 4 times 1 over 0 times -4. 4 over 0 is undefined, which means none. There are no y-intercepts. All right, we are ready to graph. Okay. Vertical asymptotes at 0. X equals 0. And x equals 4. 1, 2, 3, 4. And horizontal at 0, which means I will have to do a test value. And an x-intercept at -1. And that's it. Okay. Right off, this is a trickier one than usual. You won't typically see them like this very often. Occasionally you'll see one like this. I have a left, a middle, and a right. On the left, typically, and all the ones we've done so far, it's all at the top or all at the bottom. This one is a rare case because it has an x-intercept on this side. Usually we don't have one on that side, but this one we do. So it's not going to be all at the top and all at the bottom because that x-intercept is a cross, not a bounce. So I'm going to go through like this, or I'm going to go through like this, just depending on where I'm at. So I'm still going to pick a test value. I'm going to pick it to the left of this x-intercept, which is -1. So I'm going to pick -2. -3, -4 would have worked. Okay, so I have +4 times -2 minus 1 is a negative, over -2 is a negative. -2 minus 4 is another negative, so I have 3 negatives, which is a negative. So typically I would be all at the bottom, but since I have that x-intercept, I am approaching here, then I have that intercept to cross and then approach up here. I know that looks wonky and weird, and it doesn't happen very often. They're rare cases, and that's it for that part. Okay. Both of these had a multiplicity of 1, which means they were both odd, which means they are both the opposite direction. So this one here is coming from the bottom, and there's no x-intercept, so it's just like a little squished parabola shape here. Odd, opposite direction, so I'm not at the bottom, I'm at the top. Approaching here and there, no x-intercept, so it looks like so. Again, a little wonky on the left-hand side. Doesn't happen very often, but occasionally it does. Okay, that's it for 25. 29. Is f of x equals x squared plus 3x over x squared plus x minus 6 d va ha sa x-intercept y-intercept. Okay. I'm going to go through and factor x plus 3, and here I get x plus 3x minus 2. Now I recognize that I can reduce, but I remember to find domain before reducing. That's the only thing I do first. All real such that x cannot equal negative 3 or positive 2. Then I reduce, and everything else I find with this new function there. That's not a minus 3, that should be a minus 2. Okay, so I find the domain first, and everything else I'm going to find after. And I'm using this new function here. Okay, x equals positive 2, and it has a multiplicity of 1, so that is odd. I'm going to put m equals 2. I'll put odd later. M equals 1, not 2. M equals 1 because the multiplicity is 1. Horizontal asymptote, is it top heavy, bottom heavy, or the same? It is the same. Degree of 1 at the top, degree of 1 at the bottom. Leading coefficients, y equals 1. No test value. And since it's not top heavy, there's no slant. Remember, you're never going to have a horizontal and a slant at the same time. X-intercept, you make the equation equal to 0. The bottom is not going to count. X equals 0. And it is a cross because of the multiplicity of 1. And then y-intercept, I plug in 0. 0 over 0 minus 2 is negative 2, is 0. Okay, and we are ready to graph. Oh, and quick reminder, because we reduced, we will have a hole. Whenever you reduce a variable, an x, you'll have a hole at x equals negative 3. Set that equal to 0, you get negative 3. That's where the hole is going to exist. And why is that? Because here in our domain, x cannot equal negative 3. That's why we're going to have a hole there. So let's see what the graph will look like. Okay. I have a vertical at positive 2. I have a horizontal at positive 1, y equals positive 1. This vertical came from a multiplicity of 1 right there, which means it is odd, opposite direction. I have an x-intercept at 0. It is a cross. And we are ready. Okay, I have a left half and a right half. I don't need to do a test value, and this one's not a tricky one like the last one. It's either going to be all at the top or all at the bottom. And because of that intercept, I'm forced to be all at the bottom. So it's going to look like this, just like the ones we're used to. And then opposite direction, because it's odd, which means I'm coming from the top, and it's up here. Now, many times kids will do all of this beautiful work, even have that note there, but forget to make the hole, and then they get it wrong. Be careful. Why is there a hole? According to all of this, my graph looks correct. But the domain is x cannot equal negative 3 or 2. The cannot equal 2 is already taken care of with that asymptote. That asymptote's there, that's taken care of. X cannot equal negative 3, that's not taken care of. That's where I need my hole. 1, 2, negative 3, and I put a hole on the graph. Why there? Because that's negative 3. Now, sometimes wherever my graph is, if my graph were down here, I'd put the hole there. I go to wherever my graph is when x is negative 3, go up to that y value, and put a hole. That there is what number 29 would look like. Okay, number 31. F of x equals x squared minus 1 over x plus 1. This one's a little tricky as well, but it does come up on the test. We won't worry about the test until we get back. Okay, factor x plus 1, x minus 1 over x plus 1. I see that I can reduce, but I'm going to find my domain first. and everything else after. Okay. Domain. All reals such that x cannot equal -1. Then I reduce, leaving behind y equals x minus 1. Okay, we've talked about this before, at least I hope I have. If not, I'm going to tell you now. I do talk about it like when I go over worksheet 6, I believe. If there's no variable in your denominator, all of your asymptotes are none, and that is a test question, so you do need to know that. I will repeat it. If there's no variable at the bottom, here the denominator is just 1. It's a 2 or a 3 or a 5. If there's no variable in your denominator, all of your asymptotes are none. X-intercepts we still find by setting the equation equal to 0. Add your 1, you get 1. Y-intercept you still find by plugging in 0, and you get -1. Okay, no asymptotes, just the x-intercepts of 1, y-intercept of -1, and make your graph. Which makes sense because this is what I'm graphing right here, y equals x minus 1, a y-intercept of -1, and a slope of +1. The only thing I have to remember is that because I reduced right here, I will have a hole at x equals -1, which makes sense because my domain is everything except -1. So I go left 1, where is my graph, up or down? It's down, and I put a hole, and that there is your graph. A linear graph, a straight line with a hole. You will have something like this on the test where you, just like this, have to work from here to here, and one where you work backwards. I give you this, and you work backwards to that. Or you can leave it in factored form like that one there. It's your choice. Okay, that is it for 31. Oh, I'm going to leave it up, and I'm going to do 40 at the bottom. F of x equals x plus 4 over x squared plus x minus 6. Okay, factor x plus 4 x plus 3 x minus 2. Nothing reduces, so I'm going to go straight to finding everything. Okay. Domain, all reals, such that x cannot equal -3 or +2. Vertical asymptote, since nothing reduces, x equals -3, x equals +2. They both have a multiplicity of 1. Okay, horizontal, I take the limit as x approaches infinity. It is bottom heavy, so it is y equals 0, which means there's no slant because slant only happens when it's top heavy. X-intercepts, I make the equation equal to 0. The bottom always cancels out, leaving behind a -4. Y-intercept, you plug in 0, 0 plus 4, 0 plus 3 is 3, 0 minus 2 is -2, 4 over -6, so -4/6. All right, we're ready to graph. Okay, horizontal is 0, which means I will have to do a test value. Y equals 0. And I have two verticals, x equals -3 and x equals +2. And they both have a multiplicity of 1. We wrote that down earlier, which means they are both odd, which means opposite direction. X-intercept is -4, 1, 2, 3, 4. and y-intercept is negative 4/6. And I have a left, a middle, and a right. Far left side, this is like the one we did, I believe it was 25, this one here, where it had an x-intercept on this side, so it's very similar. It's not going to be all at the top or all at the bottom. We just have to find a test value still and figure it out. Okay, I'm going to pick a test value to the left of my x-intercept, and this x-intercept is negative 4, so I'm going to use negative 5. You can pick negative 6, negative 7, x equals negative 5, and I'm plugging it in. I'm going to plug it into the factored form. It's easier. Doesn't matter though. Negative 5 plus 4 is negative. Negative 5 plus 3 is negative. And negative 5 minus 2 is negative, which means it comes out to be a negative. So anywhere to the left of this intercept, I'm going to be on the negative side, always approaching the asymptote. I cross negative 4, had a multiplicity of 1, so that is a cross. I cross it, and nothing's bringing me back down, so I'm approaching this asymptote up here like this. Again, looks a little wonky, but it happens every now and then. Odd is opposite direction, so I'm coming from the bottom. I have that y-intercept to cross through, and no x-intercept to bring me back up, so it's going to come down like a U shape. And odd is opposite direction, so I'm coming up here at the top, like so. Again, everything works out the same except for that little tricky piece right there. It doesn't happen very often, but you should at least know how to approach it if it ever does. Okay. That is it for number 40, and I'm going to go ahead and do 33. If you don't need 33, you can go ahead and stop the video at this time. If you'd like to watch it, continue playing, and I'm going to go over it now. Okay, f of x equals 2 plus x over 1 minus x. D, va, ha, sa, x-intercept, y-intercept. Okay, there's nothing to factor, so domain is all reals such that x cannot equal 1. Since nothing factored, it looks like nothing reduces. We're going to go straight to finding everything else. X equals 1 with the multiplicity of 1, because I set that equal to 0. Horizontal is at top heavy, bottom heavy are the same. It's the same, which means I take leading coefficients. 1 over negative 1 is negative 1. No test values. Slant, none, because it's not top heavy. Set it equal to 0 to find the x-intercepts. The bottom always cancels out. 2 plus x equals 0. Subtract, you get negative 2. The multiplicity is 1, which means it is a cross. Y-intercept, you plug in 0, so you get 2 plus 0 over 1 minus 0, which is 2. And we're ready to graph. Okay. Vertical at x equals 1. Y equals negative 1. And this vertical came from the multiplicity of 1, which means it is odd, which means opposite direction. I have an x-intercept at negative 2 and a y-intercept at positive 2. And I have a left half and a right half, no test values. And I am here going to be either all at the top or all at the bottom. And according to where my two intercepts, my x and my y intercept are over here, I'm going to be at the top looking like this. Like this is a more like usual graph, not like that tricky last one we just did. Approaching the two asymptotes. Odd means opposite direction, so I'm going to be coming from the bottom on this one, which makes sense because I have no x-intercepts to touch, so I'm approaching both asymptotes like so. This is more like a typical graph you would see on a test. And that is it for these homework questions. Don't forget, you can always email me when you have questions, and I will do my best to record and post.